All right, everybody, we get into the good stuff today, factoring. So I'll split these videos into two videos so they're not long. So this first video is going to be about factoring out the greatest common factor and factoring by grouping. The next video I'll make for these notes will be factoring the trinomials where the leading coefficient is 1 and factoring trinomials where the leading coefficient is greater than 1. Okay, so we'll make them two because it probably could get very long. So I'll split it into two. Okay, with that being said, let's get started on factoring out the greatest common factor. So the GCF of two or more integers is the greatest factor common to each integer. It is the largest number that divides evenly into all of the integers. So we're going to look for a common number in our polynomials that we're given. When factoring out the greatest common factor in polynomials, we look for the largest number they share as well as most of each shared value. We will utilize the distributive property to factor out the greatest common factor from a polynomial. So normally, we distribute, right? A times B plus C would become AB plus AC. But since we're factoring, we're going to reverse this process. So we see that A is the common factor. So if A is the greatest common factor, we can factor A out. And if I factor A out, this is what we're left with, A times B plus C. So we're taking a polynomial and essentially just working backwards. Okay. Now we're going to do that with actual numbers, right? So we'll start with number 1, 3q minus 15. Okay, well, whenever we're factoring out a greatest common factor, first thing to do is look at the numbers. 3 and 15. So when I see 3 and 15, I want to know what number do 3 and 15 have in common, and what can we factor out? Well, you usually want to take out the smallest number. So between 3 and 15, we can say, let's factor out a 3, because 3 and 15 are common, right? If I put 15 and list the factors here, you'd have 1 and 15, 3 and 5, right? Those are the only factors of 15. So these numbers, 3 and 15, share a common factor of 3. So that's what we're going to factor out. So when I factor the 3 out, I write 3 to the outside. I start a parentheses. And when I factor 3 from 3q, so factoring is essentially dividing this number 3 out from each term. So 3q from 3, and when I say 3q from 3, I'm essentially saying 3q divided by 3 would leave me with q. And that's what's going to go inside the parentheses. So 3q from 3 leaves me with q minus, and now 3 from 15. So 15 divided by 3 means we would end up with 5. And close parentheses. And that's it. That is factoring out the greatest common factor. And now, of course, how do you check your work? Well, you just reverse the process. Distribute the 3 back in and see if we get the original problem. So 3 times q is 3q. 3 times negative 5 is negative 15. Is this the same as that? It is. So this means we have factored correctly, which means our answer is right there. So that is the simplified format of this given polynomial. All we have done is take out the greatest common factor. That's all. Let's try it again. 5c squared minus 10c plus 15. Once again, always look at the numbers. 5, 10, 15. What is the smallest number we can take from 5, 10, 15? Or I guess it's its greatest common factor, right? What is the greatest number that we can take from 5, 10, 15? And that number is 5. So if I factor a 5 out from this whole polynomial, I put the 5 on the outside, and now 5 from 5c squared should just leave me with c squared. 5 from negative 10c should leave me with negative 2c. And 5 from 15 should leave me with 3. And that's it. 5 was the greatest common factor, and we can't take anything else out. You can definitely check your work. 5 times c squared is 5c squared. 5 times negative 2c is negative 10c. 5 times 3 is 15. It checks out. We have factored out the greatest common factor correctly. And that's it. All right. 3, t to the fourth minus t plus 8t squared. Like I said, always look at the numbers. Now look at t to the fourth. There's no number in front of it. And if there's never a number in front of a variable, it's always understood to be 1, which means, let's look at the numbers now. 1, 4, 8. Can I factor anything out from 1, 4, and 8? And that answer is no. We cannot take any numbers out this time. So once you've looked at the numbers, and if you can't factor anything out from 1, 4, and 8, then we move on to the variables. So now we look at t to the fourth, t, and t squared. So now when you're factoring variables, you want to know what is the biggest power you can take out. So there you have t to the fourth, t, and t squared. Well, the only thing I can do here is factor out a t. That is it. T to the first is the biggest power of t I can take out. So I can only factor out a t. So if I do that, I'll put a t on the outside. And in parentheses, we have t from t to the fourth. So once again, what that looks like is when I say t from t to the fourth, it is saying divide t to the fourth by t, by the greatest common factor that we have taken out. And that would become t cubed. So that goes right in there. Minus, do it again, t from 4t. Do the same thing. 4t, take the t away, you get 4. And then plus t from 8t squared. That would just leave me with 8t. Close parentheses. We have factored it. We took a t out. And now what I like to do is inside the parentheses, just rearrange it from highest power to lowest power. And that'll finish it up. You get t cubed plus 8t minus 4. All we did here was rearrange. Okay, and there's nothing else we can do. You can check your work again. I'll put one back there. There you go. Green, purple. And if you checked your work, t times t cubed is t to the 4th. T times 8t is 8t squared. And t times negative 4 is negative 4t. It all checks out. Okay. Next. Oh boy, look at that one. All right. 8m squared n cubed minus 24m squared n squared and 4m cubed n. Let me put these on. My eyes are already feeling it. That blue light, I'll have no eyeballs by the end of the semester. Okay, so just looking for the greatest common factor. And look at the numbers first. 8, 24, and 4. What is the biggest number I can take from 8, 24, and 4? And that answer is going to be a 4. If I take a 4 out, if I factor a 4 out from each term, then 4 from 8 would give me 2m squared and cubed minus 4 from 24 would give me 6. Oh, right, 2, oh yeah, that'll work. And then m squared plus 4 from 4 would just leave me with m cubed n. So we have taken the biggest integer out. We have taken the biggest number out. We can't take anything else out. If you look at your numbers, 2, 6, and a 1. We cannot factor any more numbers out, which means we now will look at the variables. All right. So look at your m's. You have m squared, and m cubed. So remember, when you're factoring variables out, you want to take the one out with the lowest power. So if you have m squareds and m cubes, we're going to take out an m squared. So I'll have 4, and I'll take out that factor of m squared, rewrite my parentheses, so that m squared now joins the 4. And now m squared from 2m squared and cubed is just going to give me 2n cubed minus m squared from 6m squared n squared will leave me with just 6n squared. And then m squared from m cubed n is going to leave me with mn. All right, almost there. We have one more variable to look at, and that's the n's. N cubed, n squared, and n. Are you dreaming? And the greatest common factor from n cubed, n squared, n, we want to take out the lowest power of n, which is going to be just this n to the first at the end. So that's what we're going to have. So on the outside, I have 4 m squared, and now we're taking out an n. And in your parentheses, now we take n from 2n cubed, which would leave me with 2n squared, minus n from 6n squared will leave me with 6n, plus n from mn will leave me with m. Close parentheses. We cannot do anything else. Therefore, that is done. And now, if you know what you are doing, you do not have to do it step by step like I did. You can start here, and if you know the greatest common factor of the whole thing, then you can end right here and skip those 2 steps. If you know how to factor already, right? If you don't, then break it down step by step by step like I did. But eventually, you'll get faster at it, and boom, you'll have your greatest common factor. Once again, if you want to check your work, distribute it. 4m squared n squared, right, becomes 8m squared n cubed. 4m squared n times negative 6n becomes negative 24m squared n squared. And then 4m squared n times m becomes 4m cubed n. It all checks out. All right. Not bad. Next one, still greatest common factor. So look at your numbers, 116. What number would they have in common? 116. And if you said 2, that's perfect. We could start with 2, but remember, you can always go bigger. So let's say if you did choose 2, because they're both even numbers, right? If you chose 2, you'd get 50a to the 5th b cubed plus 8a squared b. And it's not a bad start to choose 2. If you have even numbers, go with the smallest number, 2. But then look at your numbers again, 50 and 8. These again are even, which means, hey, take out another 2. And you'd get 25 a to the 5th b cubed plus 4a squared b, where 2 times 2 is actually 4, right? And now you have 25 and 4, and now you can't take anything else out because 25 and 4 don't have any other number in common. So you can start by 2s, or we could have said, hey, I see that 4 is their common factor, and we could have been on this step already. So I'm going to erase it, but we're going to start off on the step right here where we take out a 4. So try to go big, right? Think greatest. So out of 116, we take a 4 out, and I get 25, because 4 from 100 is 25. A to the 5th b cubed plus 4 from 16 gives me 4a squared b. Okay, done with the numbers, right? Nothing can happen here with 25 and 4. So now we move on to the variables. A to the 5th, a squared, and remember with variables, you can only take out the smallest power you see. So from a to the 5th and a squared, the smallest power here is a squared. So that's what we'll factor out. 4a squared. And then why not do it all at once, right? Let's see. B cubed and b. We're going to take out the smallest power of b, which is that b at the end, b to the 1st. So I have 4a squared b. And now the 25 stays, but now a squared b from a to the 5th b cubed. Well, a to the 5th, a squared from a to the 5th gives me a cubed. B from b cubed gives me b squared. Plus the 4 stays, and now a squared b from a squared b. Well, a squared b from a squared b cancels, and that just leaves us with 4. And it's done. We can't do anything else. That's it. Okay. All right. Now, hopefully we're warmed up, we're ready to go. We can get this in one try, right? So let's look. 42, 14, and 7. The greatest common factor from 42, 14, and 7 is going to be 7. So I'll take a 7 out. And then, now let's look at the variables. Like I said, let's try to get this in one go. So p cubed, p to the 4th. From p cubed, p to the 4th, we had to take out the smallest power, so we take out a p. And then last variable, q squared, q to the 4th. We take out the lowest power, which is a q squared. There it is. There's the greatest common factor, 7p q squared. Now let's take 7p q squared from each term. So 7p q squared from 42 p cubed q squared. Well, let's start slow. 7 from 42 gives me 6. P from p cubed gives me p squared. Q squared from q squared, cancel. That one's done. Minus, next one. Actually, is that a plus? That's a plus, right? Yeah. Next one. 7p q squared from 14p q squared. 7 from 14 is 2. Then p from p, cancel. Q squared from q squared, cancel. We're left with 2. Minus 7p q squared from 7p to the 4th, q to the 4th. Hey, look at that. 7 from 7, cancel. P from p to the 4th, p cubed. Q squared from q to the fourth, q squared. That's it, y'all. One go, nothing else to factor out. All right, that's it. I wouldn't even worry about rearranging this one, okay? Leave it as is. Unless it does ask you to rearrange, then I would put the p cubed, q squared first, and then p squared, and then 2 at the end. But I don't think it's going to ask you to do so. All right, that's greatest common factor in one go. No step by step, right? Not bad. All right, check our work. Let me do it real fast. 7 times 6 is 42. P and p squared is p cubed. Q squared, good. 7 times 2 is 14. PQ squared. 7 times negative p cubed. Q squared is 7p to the fourth, q to the fourth. It all checks out. Just distribute it. All right, let's do it again. I'll put a number in front. So we have, again, always look at the numbers. You have t to the fifth. If no number is shown, it's always understood to be a 1. So we look at the numbers, 1, 2, 3, 4. No common factors between 1, 2, 3, 4. We cannot factor anything out, which means we move on to the variables. So I have t to the fifth, t cubed, t to the fourth, t squared. So t to the fifth, t cubed, t to the fourth, t squared. Which one has the smallest power? T squared. So we can only take out the smallest power of t squared. And then look at your other variables. I have an r and an r, but there's no r here and there's no r there. So actually, our job is really easy right now. The only thing we can factor out is just a t squared. That's it. So you'd have t squared, and let's start. T squared from t to the fifth is t cubed, plus t squared from 2rt cubed, 2rt cubed is 2rt. And then t squared from negative 3t to the fourth is negative 3t squared. And then plus t squared from 4r squared t squared. Your t squareds will cancel. And there it is. Nothing else we can do there. And again, I wouldn't bother rearranging it. All right, not bad. Okay, number 8. Doesn't look too crazy, right? Numbers first, negative 15, negative 30. Looks like the greatest common factor is going to be a negative 15. And then p cubed and p squared, we can take out p squared. There's the greatest common factor. Now let's take it from each term. Negative 15p squared from negative 15p cubed. All right. So once again, just to show you what's happening, you have negative 15p cubed from negative 15p squared. Well, one thing we know is negative over negative makes positive, but 15 over 15 will cancel. And p cubed over p squared is just p. So a p would go right there. And then negative 15p squared from negative 30p squared. Once again, negative over negative makes positive, but 30 over 15 makes 2. And p squared over p squared cancels. So you just get 2. So you would get p plus 2. And again, you can check your work by distributing. Negative 15p squared times p is negative 15p cubed. Negative 15p squared times 2, negative 30p squared. Hey, last one for greatest common factor. Okay. So, like we always start, look at the numbers. There's 7, and then now you have a negative y x squared plus 1. Well, what number is in front of that y? A negative 1. Well, you have 7 and 1, which means we can't factor anything. So we can't do anything with the numbers. Then we look at the next variables, the ones outside the parentheses. Well, I have a y here, but there's no y over there. So we can't do anything with that. So we have to leave the 7 and the 1 alone. We have to leave the y alone. The next thing we look for is something that looks common, hence the word the greatest common factor. What looks common on this polynomial? Do these look common? Do these look the same? Are these the same? And that answer is yes. And if it is common, then it must be the greatest common factor, which means we can factor it out. So the green one is the greatest common factor, so I'll write that out here in parentheses. And then, what is left over if I just factored out these two? Or we can do like we always say, what is x squared plus 1 from 7x squared plus 1? The x squared plus 1s will cancel, leaving you with just 7. And then, what is x squared plus 1 from negative y x squared plus 1? And once again, your x squared plus 1s will cancel, leaving you with just negative 1y, or negative y. And that's it. That is greatest common factors. All right. We have now reached factoring by grouping. And what we're going to do here is we're going to be given 4 terms. The only way to factor by grouping is if you're given a 4-term polynomial. And the very first thing to look for to make our work easy is to see if there's a greatest common factor. If there's not, then we proceed to the next step, where we take the 4 terms and we group them into 2, and we find a common factor in those 2 terms, and then we factor by grouping. Yeah, doesn't sound tough, right? So let's try it out. Okay, so first thing, here's our 4-term polynomial. First thing you want to look for is a common factor. So remember, you always look at your numbers. That's a 1a, 1b, 3, 3. So from 1, 1, 3, 3, we can't take anything out. And then you have a, b, a, b. Since not every term has an a and not every term has a b, we can't factor that out. And then x, x, no x over here. There's no x here, and there's no x there. So this means we actually do not have any greatest common factors. So we can proceed to factor by grouping. And to factor by grouping, what we do is we group the first 2 terms, and we group the last 2 terms. And we look for a greatest common factor in our groups. So we will start with ax, bx. What is the greatest common factor in ax, bx? There's an x there, there's an x there, which means we can factor out an x. And that'll leave me with a plus b. Now, very important, this sign must always come down, right? So we'll put a plus there. It's a little trickier when you get to a minus sign. So you can bring the sign down, or we can wait to find out what we factor out of the next one. So let's look at the next term. You have 3a plus 3b. What is my greatest common factor here? You have a 3 and a 3. So we're going to factor out a 3. But the 3 is also going to be positive, which means it will go along with this sign. So we are factoring out a positive 3. And then inside the parentheses, I am left with a plus b. Okay. The biggest part of factoring by grouping, well, is factoring and looking for a common factor. So whenever you factor by grouping, after you have completed this first step, we look to see if we have a common factor. So what we want to know is, does this a plus b, right? Does this term look exactly like that term? Are these terms common? Are these terms the same? And that answer is yes. So if we have a common factor of a plus b, well then guess what we can do with it? We can factor it out. Which means when you factor it out, you'll get a plus b times whatever is left over. We take a plus b from x times a plus b, and that'll just leave me with x. You take a plus b from 3 times a plus b, and that'll leave me with plus 3. That's it. That is factoring by grouping. You take a 4-term polynomial, group it into 2 terms, find a common factor, factor out the greatest common factor, and done. And if you write it like this, that it works as well. That's the same answer. So you can have either or. All right. So factoring by grouping. Let's do it again. All right. 2x plus 6 minus x squared minus 3x. Okay. So from this, I can see there are no greatest common factors at all. So this is just something you have to notice, right? You have 2, 6. So go over it. 2, 6, 1, negative 3, nothing. X, no x, x, x. No greatest common factors out of the whole thing, which means proceed to factor by grouping. Put the first term together. Put the last two together. Include the negative with it. So negatives is where it can get tricky. So we have grouped them together. Now we look for a common factor in both groups. So on 2x plus 6, you see you have 2 and 6. The biggest number you can take out is a 2. So you take a 2 out, and when I factor a 2 out of 2x plus 6, I get x plus 3. And then we don't want to bring this sign down. Don't do that when it's a negative. Bad mistake to make, okay? So I wouldn't bring any sign down until we actually find the greatest common factor in the next group. So here you have negative x squared and negative 3x, where your common factor is x. So what we're going to do here is factor out a negative x. We're going to take a negative x out. So I'm going to put minus x. That's my factor from those terms. And then parentheses. Now, negative x from x squared, from negative x squared, negative over negative becomes positive. So this is going to give you x. And then negative x from negative 3x, negative from negative gives me positive, and the x's will cancel, giving me 3. Okay. Now, the rest is do those binomials, do those factors look the same? Is this x plus 3 the same as that x plus 3? And the answer is yes. So we write it as x plus 3. You factor out that greatest common factor of x plus 3, and what is left behind? The 2 and the negative x are left behind. So you'd have 2 minus x. That's it. Oh yeah, and a way to check your work is to FOIL everything out. Yeah, let's run through that really fast. If I FOILed everything out, I'd get 2x minus x squared plus 6 minus 3x. Now, sure, it doesn't look like the one above, but if you did some rearranging or just match the terms, we would have the same. Negative 3x, negative 3x. Negative x squared, negative x squared. 6, 6. 2x, 2x. It's the exact same thing. There it is. So you can always check your work by distributing again. Yep. All right, 3. Let's do it again. I do not see any common factors again, so straight to factoring by grouping. And we look at 5x and 15. So 5 and 15. Oops, different color, right? 5 and 15. I take a 5 out. Then you get x plus 3. And then from x, y, and 3y, I see that y is my common factor. So I take a y out and a positive y at that. So positive y, and that'll leave me with x plus 3. And once again, these look the same, so factor them out. And all that's left over is the 5 plus y. Done. Not bad at all. Again. 4, once again, I do not see a common factor. So, and you don't always have to look for a greatest common factor. You can begin by factor by grouping, and what you end up with will lead you to find the greatest common factor at the very end. So you can find it at the beginning, or you'll have to find it at the end. It doesn't matter. So right now, we can just jump into factor by grouping without even checking for a GCF and go from there. So group those two with the negative. All right. And 2x minus 6, 2 and 6. You take out a 2, and that gives me x minus 3. Negative xy and 3y, I see that y is my common factor, but I'm not going to take out a y, I'm going to take out a negative y. Because if I take out a negative y, that changes the signs of these two terms. Negative y from negative xy, remember, negative from negative makes positive. So negative y from negative xy, your y's will cancel and leave me with a positive x. And then negative y from 3y, well, negative from positive means negative, right? So negative from positive means negative, the y's will cancel, and now I'm left with a negative 3. And of course, you can check your work from this step. Say, am I on the right track, right? Am I on the right track? And if you distribute it, negative y times x is negative xy. Negative y times negative 3, negative times negative is positive, giving you that positive 3y. It checks out. And now, do these terms look the same? Yes. Factor them out. Factor out the x minus 3. What's left over? The 2 minus y. Okay, perfect. Let's keep going. All right. So like I said, I'm not even check for greatest common factor. Either we find it now or find it later. Let's just jump into grouping. So group these two, group those two, and look at 2x plus 1. You have a 2, you have a 1. Nothing there. So what do? Well, since there's nothing we can factor out from there, we're just going to bring it back down. So in parentheses, well, I'm going to bring it down and put it in parentheses. I'm going to say parentheses 2x plus 1. So nothing could factor out, so we leave it alone. But now, let's look at the right side. Oh, should change the color, right? So if you can't take anything out, we just bring that down. Nothing happened there, right? But let's look at the next term and see if we can figure something out. So 4 and 2. From 4 and 2, I can take out a positive 2. So a positive 2. But also, I have y and y. I can take out a positive 2y. Now, when you factor out a 2y from 4xy gives me 2x. 2y from 2y cancels. And whenever we cancel something by factoring, we should always get a 1, not a 0. So when I say 2y from 2y, we know that anything over itself is always 1. So that's what should go right there. Okay. Well, we have taken the greatest common factor from the group on the right, the term on the right. And now we run into, does this term look like that term? And those terms look exactly the same, which means you can factor them out. So you'll factor out the 2x plus 1. But now what is left over? And if you're thinking just 2y, that is incorrect. Because we always must account for the number that is in front of anything. And that number is a 1. So what's actually left over is 1 plus 2y. And that's it. Tricky, right? Makes you think. Six. Just jump straight into it, right? Group and group. Okay. Well, first one, 3 and 15. I can take out a 3. I have a j, but no j over there. So we look at the next variable, k and k. I can factor out a 3k from the first group, which means if I factor out a 3k, that leaves me with j squared plus 5. Trying to draw the perfect j. It's not working. Try one more time. That's going to have to work. Okay. Then we look at the next terms. You have a j squared and a 5. And this is just like the one above. We can't factor anything out of this. So we bring it down. And there's a plus in front, right? That's the connector. And when we bring it down, always write it in parentheses. Hey, that j is better, I think. Or is it the same? Whatever. Okay, So we bring it down. We can't factor anything out of it. But then we move on to the next process. Does this j squared plus 5 look like that j squared plus 5? And the answer is yes. So since they are the same, since they are common, factor it out. J squared plus 5. There we go. And what is left over? Remember, this is just like the one above. What magical number is in front of that j squared plus 5? A 1. So we get left with 3k plus 1. And that's it. It may seem like magic, because it is. Math magic. 7, jump in again. Group those two. Group those two. Okay, let's start. 2 and 6, I can take out a 2. A and A, I can take out an A. And then you have a B squared and a C, nothing happens there. So the only thing we can take out is a 2A. So I take out a 2A from the first term, that leaves me with B squared minus 3C. And then look at the next group. You have a B squared and a 3C. Nothing happening there. So remember, if we can factor it out, we bring it down with the sign plus and put it in its own set of parentheses. Hey, and this is like the last two. Does this one look like that one? Yep. Greatest common factor of b squared minus 3c, so factor it out. You take a b squared minus 3c out, and what's left over? And remember, we can put a 1 right in there, squeeze it in there, right? And what's left over is 2a plus 1. And there it is. So, in a sense, you can say from b squared minus 3c, the only number you could factor out is a 1. You can always factor out a 1. You can even factor out a negative 1, but that comes later, I think. Not in factor by grouping yet. Okay. So if you can't take anything out, take a 1 out. That's what we did for the last 3, right? Including this one. All right, number 8. Once again, just jump into it. Group the first 2. Group the last 2. And find the greatest common factor in each. 14 and 7, that is 7. W to the 6th, W to the 6th. Take out a W to the 6th. X to the 6th, no X to the 6th on that term. So we can't take out an X to the 6th. We can only take out a 7W to the 6th. And now 7W to the 6th from 14W to the 6th, X to the 6th. 7 from 14 is 2. W to the 6th from W to the 6th, cancel. And you're left with 2x to the 6th. Plus 7w to the 6th from 7w to the 6th. You are taking that from itself. So again, we're saying 7w to the 6 from 7w to the 6, and anything over itself is always 1. So you get a 1 there. Okay. And then negative 2x to the 6, negative 1, nothing in common. Hey, I did mention it above, and I did say it wouldn't be on factoring by grouping, but now it is. So for this one, you don't see anything common in negative 2x6 and negative 1, but we do see that, remember, if you don't find anything common, you can factor out a 1, or you can even factor out a negative 1. So from negative 2x to the 6 and negative 1, I'm going to factor out a negative 1. If I factor out a negative 1 from negative 2x to the 6, negative from negative makes positive. And then negative 1 from negative 1, once again, negative from negative makes positive. So it's a nice trick, right? You can factor out a 1, or you can even factor out a negative 1. And now, do those look the same? They sure do. So factor them out. And if I factor out a 2x to the 6 plus 1, what is left over? All right. Not bad. Number 9. All right. Last one for factoring by grouping and for this video. We call this factoring part 1. Greatest common factor and factoring by grouping. So just jump into it. Group the first 2, group the last 2, and let's hope for the best. 18 and 4. You can take out a 2. P to the 4th, no P to the 4th here, but then you have an X and an X. So our factor is 2X. Parentheses, and now we're taking 2X from these two terms. So 2 from 18 is 9. And then the X's will cancel. And you're left with 9 P to the 4th minus 2X from negative 4X is just negative 2. There's the first one. Second one, negative 9 and 2, nothing. P to the 5th and P, we got something going on. P to the 5th and P, whenever factoring variables, you factor out the lowest power. So the only thing we can take out of here is a P. But I'm going to take out a negative P. And there's always a reason for this, because if I take out a negative P, it's going to change the signs of these two terms. Negative P from negative 9P to the 5th, negative from negative makes positive. So you'll get a positive 9, and P from P to the 5th gives me P to the 4th. And then negative P from 2P, positive 2P, negative from positive makes negative. Your P's will cancel, and you're just left with negative 2. Okay. Do these look the same? They sure do. And since they look the same, factor it out, and what is left over? And that's it. That is factoring by grouping and greatest common factor strategies, right? Next, we will be factoring trinomials when a is 1. So that is going to be on another video, because this video is probably 30 or 40 minutes long. I'm not trying to make a 3-hour video. Okay, that's it for now.